As part of understanding the configuration files and properties, we have made some changes with respect to node manager capacity. We have increased memory to 6 GB on each node manager and number of vcores to 6. By rerunning this random text writer, we will see how it will impact the performance and how the cluster is being used, and then we will take it further. As we have run this job already, I have connected to the gateway node, and first I will remove the files which are generated. The files are generated under user itversity random text writer. First we are deleting that directory completely. As the directory is deleted, now let us actually rerun this job by copy pasting this. It will start the job in a moment. First it will create application master, then it will create the task to process the data and write into the file system. It uses 30 map tasks to process the data. However, it can only run up to the capacity of the cluster at any given point in time. We'll get into the details in a moment. You can see there is a tracking URL for this job. You can copy this and you can go to the browser. Before pasting this, make sure SSL is on. I have already started SSL in another terminal here, and hence this URL will work for me. If it doesn't work for you, you need to make sure SSL is on from your system onto the gateway node so that these URLs work. Now you can see the job details. It takes 30 map tasks to process the data. You can click on this and you can actually get the details about how many map tasks are running at this time. Out of 30, 13 is pending, only 17 is running. And what is the capacity of our cluster? We can go here and click on about, and you can see that the capacity with respect to memory is 18 GB and with respect to vcores is 18. And here it is using the entire 18 GB memory and entire 18 vcores, which means it is actually using 18 tasks or 18 containers to process the data. However, when we get into the job level details, we can only see 17 jobs, 17 tasks running. But if we go back to the main page of the job, you can see running containers as 18. The reason why it is 18 here and only 17 when it comes to map tasks is one of these container is running application master. To get the details with respect to application master, you can click on this. To get the details with respect to the job that is being monitored by application master, you can click on this tracking UI. It will take us to the same URL which we have copy pasted from here, and it will start giving the details with respect to the job. Earlier, when we ran this job, at that time the capacity is only 3 GB from the perspective of memory and 2 vcores from the perspective of vcores, and hence it might have used only 3 degree parallel. There might be only 3 containers that are processing at any given point in time. Now there are 17 containers that are processing, and out of those 3 containers, one will be application master. So there are only 2 containers which are actually processing the data until all the 30 are done. That's why it took almost 6 minutes to complete the job. After making these changes, now let us see how long it will take. It should be done relatively faster. However, because our servers are not very powerful, as we have only 2 CPUs and 2 cores in each CPU, which means there are only 4 CPUs and we are using 6, and we have others also running, and hence you will not be seeing much of a difference with respect to performance, but still you will see some difference. Okay, already 70% is done. Let us see. Yeah, now 100% is done, and it took only 190 seconds. So from 390 seconds or 349 seconds or something, I do not remember exactly, it came down to 190 seconds, and hence the performance is much better. On a bigger cluster, this would have been much better. Okay, so this is how you can actually see the impact after making those changes by increasing the capacity for our node manager on each node. Instead of using 3 containers at any point in time, now it is capable of using 18 containers. As we have created 30 GB of data, now let us run a couple of Mapreduce jobs to understand the behavior of overriding certain properties. So first let us actually review our files. You can run hadoop fs-ls user itversity random text writer. There are 30 files in it, and each file is 1 GB in size, very close to 1 GB. Now let us see how many blocks are there for this 30 GB worth of data. For that, I can run hdfs fsck, and then the path is nothing but user itversity random text writer, files, and blocks. Locations are not that important. The number of blocks for all these files is very important. We have 30 files and there are 270 blocks. Each file is a bit more than 1 GB. That's why there are 9 blocks for each file. That being said, now let us run the Mapreduce job by just copy pasting this. We are again using Hadoop Mapreduce examples, but in this case we are using word count rather than random text writer. The input path is user ITversity random text writer. Output path is user ITversity word count. And here I am using yarn instead of Hadoop just to show that we can run the Mapreduce jobs either by using Hadoop jar or yarn jar. So I'm just copy pasting this from here to here and hit enter. It will create a Mapreduce job or a yarn application. We can copy this tracking URL, go to browser. It works if shuttle is on. For me, shuttle is already on. So in your case also make sure you enable shuttle onto the cluster through gateway node, and then you should be able to see this. You can see map tasks are 270. Why 270? Because there are 270 blocks associated with these map tasks. And it will take a while because it has to process the entire data. Once this is done, we will rerun this job again by overriding certain properties such as input min file size and also number of reducers. So map tasks are 270 because we have 270 blocks for our files, whereas when it comes to reduce, it will use 3 reduce tasks to process entire data to perform the word count, which might be overkill. We should be able to increase these reduce tasks also. So when we rerun this again, we will actually tweak the split size and also number of reducers, and we will see the impact on the cluster, and we will take it further. This will take a while to run. While it is running, let us understand how we can actually get the details with respect to the runtime behavior of this job. For every job, there will be certain properties which will be impacting the behavior, and those details can be retrieved by clicking on the configuration. If you click on the configuration, it will actually give you the properties in a table, and you should be able to search for whatever property you want, and you can actually see the details. You can see here there is a search bar, and these are the property names and these are the values, and it actually tells us from which property file it actually getting this value from. So there are a bunch of them. There are 850 entries like that. And here for our discussion, the most important properties are nothing but the Mapreduce input file input format split min size. Let us see what is the value for it. It is 0. So by default, it uses the number of blocks to determine the number of map tasks. And then other property is Mapreduce job reduces. And you can see it is 3. This is the value set by the Cloudera on the cluster. We can override these things at runtime while submitting the job, and it will impact the job significantly. That being said, let us also review the properties which we have seen earlier as part of answer.xml and mapreduce.xml. First, let us look at Mapreduce map memory MB. It is 0, which means it will actually pick up the minimum memory configuration from the yarn. Let us actually look at the value of this, and you can see it is 1 GB. So based upon this 1 GB of memory and 1 vCore, as we have 18 GB memory and 18 vCores on our cluster, it is using 18 tasks to process the data. Whether we run random text writer or word count, it is using 18 tasks to process the data. You can actually see the details here. Okay, now the map tasks are complete. Okay, this is a different job. This is not the right one. I have to go here and click overview, and you can see there are 17 tasks that are running at this time, and another task is nothing but, or another container is nothing but application master. So 17 map tasks plus 1 application master is 18, which is our total capacity of the cluster. In this case, the job is taking way too much of time, and hence I'm killing, so that I can actually demonstrate how to override the properties and show you the behavior. For this, we don't need to wait until the job is done. So I killed it. If you say Control C and kill it, still the job might not be completely killed. To make sure it is killed properly, you can run this command called yarn application list and hit enter. It will actually show you the currently running jobs. You can see that the job is still running. You can actually pick up this application ID and you should kill by saying yarn application kill and then application ID. We'll actually walk you through all these different yarn based commands at a later point in time, but for now this is how you can actually kill the job completely. Now you can go back to the browser and go to the cluster, click on about and then click on running. Make sure nothing is running, and then you have to clean up the remnants of the earlier run and you have to restart the job. So this will actually delete the output directory which we have passed as part of the earlier run. Once that is deleted by running this rm-r command, we can actually run this yarn-jar command. Now we are actually overriding these two properties: Mapreduce input file input format split min size and Mapreduce job reduces. Okay, so let me copy this one and paste here and hit enter. Now it will actually start a new job, and you can see that it is using only 150 as splits. Earlier it have used 270 as splits. And now you can actually go to this tracking URL and see from the web UI also. There will be 150 map tasks instead of 270, and then 8 reduce tasks instead of 3 because we have overridden that property as well. You can see here, reducers will be 8. When maps are done, reducers will pick up and process the data by performing the aggregation, which is nothing but word count. That being said, you can click on this URL and go to the job related details. As part of job, we can get the configuration by clicking on this. Once you click on the configuration, you can get these property names from here, which are overridden using -D. And then you can paste it here, and you can see it is 256 MB, not 0. Same is the case with mapreduce.job.reduces. It is 8. Earlier it is 3, and you can see the value came from the command line. Okay, so this is how you can actually override the properties. That being said, without overriding the properties, it used 128 MB as the split size, which is nothing but block size that is used to create those files in HDFS, and created 270 map tasks to read, and then 3 reducers to aggregate. The number of reducers are inherited from the number of nodes in the cluster, which is set as default by Cloudera. After overriding split size in 256 MB, the number of mappers are 150 and reducers are 8 as hard coded. Here it is not 12, it is 3 when we did not override the property. I might have ran it on a 12 node cluster, and at that time there might be 12 reducers. That's why it is reflecting 12 here. Here the idea is to only show how to override the properties, not how to determine the split size and number of reducers. It will be covered as part of performance tuning course in detail.